Center of gravity, a point where the whole weight of the body appears to act vertically downward, is called center of gravity. For example, a body is made up of large number of small particles, and the weight of every particle is acting in the downward direction. So the weight of every particle is acting in the downward direction due to the force of gravity of the earth. So this force of gravity which is acting on these particles is equals to the weight of every particle. When we will add up all the forces which are acting on a body, so that will becomes a resultant force. So that weight will becomes equals to resultant weight. So there is a point where whole weight of the body appears to act vertically downward. That point is called the center of gravity. Center of gravity of some symmetrical objects. The objects which have the proper geometry, we have to find out the center of gravity from those objects. Uniform road. So in uniform road, we know that this road is made up of large number of small particles, and the weight of every particle is acting in the downward direction. So weight, when we will find out the resultant force, so that will becomes equals to resultant weight, and which is approximately equals to the center of gravity. So in uniform road, the middle point is the center of gravity of the uniform road. In a rectangular sheet, so in the point of intersection of its diagonals is the center of gravity of this rectangular sheet. In a square diagram, the point of intersection of its diagonals, this is called the center of gravity of the sphere. In a uniform circular disc or in a circular ring, instead of intersections we are drawing the diameter. So this central point, this is called the center of gravity of the circular disc, and the central point, this is called the center of gravity of the circular ring. In triangles we are drawing medians. So the middle point of the medians, that is called the center of gravity of a triangle. And in a hollow cylinder, the middle point is also called the center of gravity of this hollow cylinder. Center of gravity of an irregular shaped thin lamina. So if we have a irregular shaped cardboard, so how can we find out the center of gravity of irregular shape object? So the center of gravity of irregular shape object can be found out by the use of a plumb line. What is a plumb line? It consists of a metal bob which is attached with the help of a string, and this metal bob is either made up of a lead or a brass, and when we will suspend this metal bob freely, so it acts in vertically in the downward direction because the weight of the metal bob is acting vertically downward direction. So the center of gravity is exactly below at its point of suspension. After that, to perform an experiment, we will take the irregular shape piece of a cardboard, and then we will make a 3 holes on this cardboard, hole A, B and C, and one by one we have to pass the cardboard through the holes. After that, we will fix the nail on the wall, and then we will attach the cardboard with the help of a nail. Then we will pass the plumb line through the hole A. After attaching the plumb line, we will draw a line. So then we will pass the cardboard through the hole B. After that, we will draw a line from point B, and then we will pass the cardboard through the hole C, and then we will also draw this line So after repeating this process 3 times, we will see the point of intersection of all the 3 lines is same, is common. So this point is called the center of gravity of the irregular shape cardboard.